Hello! In this video we will talk about serial communication, how Arduino boards use it, and some theory about it. Wired communication is divided into serial and parallel communication. In serial communication, the data bits are sent sequentially. Depending on whether data is only sent or both sent and received, one or two wires are required. The sent signals are square waves with two voltage levels representing the bits 0 and 1. More in-depth information about the signals in the theory part. The Arduino uses serial to communicate with computers and other devices. All Arduino boards have at least one serial port, which can be used via the USB or the RX and TX receive and transmit pins. Serial is often used for debugging purposes, as the Arduino IDE has a built-in serial monitor and plotter, which can be used to show and send data to the board. When using serial with an Arduino, remember to specify the baud rate of the sending and receiving devices to the same value. In the same way, the line endings should match so the data is interpreted correctly. When using serial with, for example, an Arduino Uno, note that the USB and the RX-TX pins use the same serial port. This means that they can't be used at the same time. If you want to use multiple serial interfaces, you can try the software serial and AltSoft serial libraries. Be aware that these libraries can have conflicts with other functionalities and libraries. We are now demonstrating an example code from the Arduino IDE. The code can be found from File, Examples, Software Serial example. In the example, two Arduino boards are communicating with each other with serial. The sent messages are shown on the other Arduino's serial monitor. We use the software serial library as the Arduinos need to use two different serials at the same time, one to the computer and the other to the second Arduino. To follow along, you will need two Arduinos and some hookup wires. Connect the RX and TX pins of the Arduinos. Remember that the transmit of the first Arduino should be connected to the receive of the second Arduino. This is because the pins are marked with respect to the device itself. Also connect the grounds of the boards together. Then the code. First, the software serial library is included and a new serial object created. In the setup function, the normal serial and software serials are initialized with respective baud rates. In the loop, we first listen for data from the software serial port, that is the other Arduino. If data is present, it's written to the normal serial, that is the serial monitor. The same logic is used for the normal serial. As data is available, it is written to the software serial. The most basic serial communication is when data is only sent in one direction. This is called a simplex connection and requires only one wire. Half duplexing is when the devices take turns transmitting data. Even in this case, a single wire is enough. If the transmitting is done simultaneously, the connection is called full duplex and two wires are required. The baud rate, sometimes called symbol rate, is used by the communicating devices to interpret the incoming signals. It's important that the baud rates between two communicating devices are the same. On a signal level, there are many different implementations and standards for serial communication. The most common ones are the TTL and RS232. Transistor-transistor logic, TTL, is used by microcontrollers, while RS-232 is used by most computers. They both use square waves to relay information, but the voltage levels are different. TTL uses 0 volts to represent the 0 bit, and the operating voltage 3.3 volts or 5 volts to represent the 1 bit. RS-232 uses negative voltages to present ones and positive voltages to represent zeros. Because of the different voltages, one must be cautious when building own connections between different serial devices. That's all for this video and for the series. Hope you've enjoyed.